Hello everyone, I welcome you all for this AS Online live session. In this live session, we are going to discuss the solutions for the GATE 23, the civil engineering paper which was held in the afternoon today, that was 12th February 23. And one important thing is, all the questions which we are going to discuss here with the solutions, these are all the questions which you have gathered from the students, from the memory base. Please understand, these are all memory based questions which you have gathered from our students. There may be some variations, small variations in the data. Moreover, the options of each question, the order might be different. So we have tried our level best to include as much as possible the accurate questions, but maybe there may be unknowingly small variations will be there. Please understand, they're all memory based questions. So let me proceed. So I'll start the solutions for the some of the geotechnical questions which are available so far. Like that, first we begin the discussions with the available questions. Later on, whenever you get some additional questions, we'll be adding solutions subsequently. So I'll begin with first the geotechnical engineering subject. This is one of the question there. As you see there, it is a circular pile. You are given the diameter there, diameter given, length of the pile given, that is 8 meters. So homogeneous soil, we have a uniform C value here. The C value given directly 25 kilopascals. ED weight of soil is given, and addition factor, nothing but alpha is given. The main question is here, what is the allowable load capacity of the pile with a factor of safety of 3? So mind you, it is a clay soil, you are asked to find the allowable load capacity of the pile. So for this allowable load capacity calculation, the gamma of the soil may not be necessary because alpha is given here, you have to use the alpha method there. So I use the direct equation for the safe load capacity of a single pile. The formula what to use is the allowable load with a factor of safety. So 1 by factor of safety, area of the pile, Cu value at the base, the bearing capacity factor NC, plus AS alpha into Cu. So I have taken here both the end bearing resistance as well as the screen frictional resistance. So further, if I elaborate, 1 by factor of safety, in the place of the area of the base, I write that formula for the calculation of the base area, pi by 4 d squared, cohesion value at the base, bearing capacity factor NC, the total surface area of the pile, pi d, that gives you the perimeter into length, pi dl gives you AS, and then we have alpha and then the Cu. So mind you, in this question, it is a homogeneous soil. The CUB cohesion at the base and the surface cohesion both are same. So here the CUB base cohesion, surface cohesion both are same, and that is given already as 25 kilopascals. So when I substitute data here, the factor of safety given, that is 3 pi by 4. I use the MKC, the meters of diameter here in terms of meters. So 0.6 whole squared, the CUB 25. And bearing capacity factor NC, I think students have not given us the bearing capacity factor. I think it's not necessary also, because you know all that in the case of a clay soil for which phi value is 0, you can take the bearing capacity factor NC value as 9. So the same 9 I am going to assume here, bearing capacity factor 9 plus pi dl, pi diameter 0.6, length of the pile given already, it is 8 meters. Alpha value given, one addition factor. C value it is 25. The remaining is nothing but the mathematical calculation. So if you use the calc, if you work out, the calculation will give you the allowable load as 146.8 kilonewtons. So friends, this is the answer, allowable load capacity of the single pile, 146.8 kilonewtons. Now let us move to the next question. Next question. It's a very simple direct question. UCC test. It's nothing but abbreviation for the unconfined compression test. You are given the soil as saturated clayey soil. You all know that for a saturated clayey soil, the phi value you can take as 0. Undrained friction angle you can take as 0 because the clay is saturated. It got failed under an axial stress of 76 kilopascals. So you are given QU, unconfined compressive strength QU value as 76 kilopascals. The question here is, what is the undrained cohesion? You are asked to find the CU value. It's a very simple objective question, 1 mark nature, is visually we discuss in every class. So in the case of phi value 0 for unconfined compression test, we have the undrained cohesion, simply it becomes half of the unconfined compressive strength. So it comes to be Q value 76 by 2, it is going to be 38 kilopascals. So this is the answer, 38 kilopascal is the undrained cohesion there. So next question. So this looks somewhat lengthy, but this can be easily done by the students if you have any idea about the stress path. So in this question, mainly you have to look at what is given along the x-axis as well as along the y-axis. You can see along the x-axis P. So the P is nothing but here. If you see this stress element soil, it is sigma V plus sigma H upon 2. And as well as if you see Q, the Q is equal to sigma V minus sigma H by 2. This is what you have to mainly observe there. The question here is, you are given the initial condition of the soil. The point O indicates the initial stress condition of the soil element. This is the point O, which is the initial stress condition. The stress path OP, you are given already there, the stress path OP. For which of the following conditions is going to be possible? One main clue is to be noted here. The stress path OP is given a slope of 1:1. Nothing but the slope angle is 45 degrees. So whenever the slope is 45, you all know that x and y coordinate must be same. So whenever the P and Q, I mean to say, whenever the delta P, the delta Q are same, then only you are going to get the straighten with a slope of 1:1. Now let us examine this. If you see A, sigma V is increasing and sigma H is decreasing. It is not going to give you delta P, delta Q same. So this cannot be the answer. Next option, sigma V is decreasing and sigma H is increasing. If you see 1 plus with minus, if this is the condition, it also will not give the slope of 45 degrees. Now next one, sigma V is increasing and sigma H is constant. Please observe this. Because sigma H is constant, this variation is 0 because it is constant. So what is said there? Delta sigma H is 0. No variation, sigma H is constant there. Because sigma H constant, delta sigma H 0. So this is going to be 0 and this is also going to be 0. Therefore, whenever sigma is increasing and the sigma H is constant, the delta P is going to be delta sigma V and delta Q also going to be delta sigma V only. It means the P and Q are increasing by the same magnitude. The increase in the X, the increase in the Y both are going to be same. That's why we are going to get 45 degrees sloping line. So therefore, the answer must be the C. So C is the answer here. C is the answer. So this is the solution for this question. You may recall, in classes we discussed that different stress path, one for the vertical loading increasing, other one for the vertical load decreasing, other one for the active, other one for the passive. This is an example what we normally give in the class for the vertical stressing, nothing but loading on a what you call footing, loading on a footing. There only you have the sigma V increasing and the sigma H constant. Another way, shortcut way to discuss the solution for this question. Next, this is somewhat a different question. A vertical sheet pile is provided in an anisotropic soil. This is the point where you have to be careful. It's not an isotropic soil, please catch the point. Anisotropic soil. anisotropic in terms of permeability coefficients. It means in this case, the permeability in the horizontal direction is not equal to permeability in the vertical direction. So this is anisotropic soil in terms of coefficients of permeability. So you are given Kv and Kh, they are not same because anisotropic soil. So to construct a flow net for isotropic conditions, it means this given anisotropic soil you have to convert into an equivalent isotropic condition. That too, keeping the horizontal scale constant. So what should be the sheet pile depth to be scaled? So the factor you have to calculate here. It's nothing but what we discuss in our Seepage chapter, how to convert anisotropic soils into isotropic conditions. There we use one differential equation in terms of for the continuity. I may recall like this. Quotient of permeability in the horizontal direction, dou square H by dou x square plus Kv permeability in the vertical direction, dou square H by dou y square, that is equal to 0. So this is the equation of continuity, but it is not a Laplace form. So to convert into Laplace form, we have to transform the dimensions there. What he said there, horizontal scale has to be kept constant. It means keeping the x direction constant, the dimension constant, you have to vary what you call the vertical dimension. That is why you have to transform the section keeping the x direction constant but varying the y direction. So to make it what you call into Laplace form of equation, what you can do is like this. Dou square H upon dou x square plus dou square H upon dou y squared. So KH goes this side. So this becomes something in this style. So still it's not a Laplace form. So to convert to Laplace form, we transform this equation something like this. So in the place of dou square H by dou y square, what you can write is dou yt squared, and that becomes 0. Now you can see this equation become what you call a Laplace form. So for this you can consider what you call the flow net here. The question is how much you have to transform this what you call the y direction dimension. You can see here, you can see there. So this value what I have written, it must be equal to this dimension. So you can see dou yt squared is equal to kh upon kv dou y squared. So this you can further convert like this, square root of kh upon kv into dou y. So in other words, finally when you work out, the transformed y dimension means vertical dimension is equal to square root of kh upon kv into y. It means if you want to keep the horizontal dimension constant, if you want to vary the vertical dimension to convert Laplace transform, you have to take the y dimension, you have to be transformed by multiplying with this factor. So therefore, the scale factor what you are supposed to use in this solution is nothing but you can see here square root of kh by kv. Where is it? Square root of kh by kv. Square root of kh by kv. So this is the answer for this question. So this solution I have brought from the continuity equation and then converting into Laplace form. If you are smart, of course you are always smart when you prepare seriously for the GATE examination. In the classes we discuss generally, we keep the vertical dimension constant and we vary the x direction. That is what you see most of the textbooks what you have on the Seepage. You know, material also you can see we keep y constant and x is varying. Whenever you want to vary x value, we multiply with the square root of kv by kh. But here the question is reverse. You have to keep x value constant and you have to vary y value. Therefore, instead of square root of kV by kh, you have to simply take inverse. Square root of kh by kV. That is a shortcut way how you can solve this question. Square root of kh by kV. So this is another question on the Seepage. So these are the 4 questions what I have so far with me. There are a few more questions in the GT subject. Meanwhile, when my other colleagues are discussing, I will try to gather those questions from the students' interaction. So I request my next colleague to come and discuss the other subject.
Good evening. We'll talk about transportation. Can you hear? Voice is okay? Yes, we'll talk about transportation. As per the memory-based questions are concerned, I received very few questions on transportation in the evening session, and this is one of the questions. Stopping site distance is equal to, as you all know, stopping site distance is having 2 parts. One is the lag distance and the other is the braking distance. Lag distance is the distance traveled by the vehicle during reaction time of the driver, total reaction time of the driver, and the other is the braking distance. So you can go by the process of elimination, especially in multiple choice question. It is given as only braking distance. So I am eliminating this, and coming to the braking distance plus perception time, maybe the distance traveled during the perception time. Actually, this must be the distance traveled by the vehicle during perception reaction time. So here only perception time is given, I can eliminate this. The 4th option is distance traveled during perception time. Here braking distance is gone. So the most appropriate and most suitable option is option B. So SSD is equal to braking distance plus distance traveled during total reaction time. So option B. Next, coming to this extra widening depends upon, as per the IRC 86, extra widening is having 2 parts. One is mechanical widening and the other is psychological widening. Mechanical widening, NL square by 2 r, their number of lines are required, and longitudinal gradient nowhere related in extra widening, and even super elevation is required on horizontal curves, not on extra widening. Radius of the curve is required. So it may be a multiple select question. Here the right options are A and D, including velocity of the vehicle. So extra widening depends on the speed of the vehicle also, especially psychological widening depends upon speed. So the most appropriate correct answers are A and D now. Coming to this question again, with the increase in percentage of bitumen, which of the following statements is or true? So I want to check up the true statements among the 4. These are all based upon the Marshall graphs, Marshall mixed design graphs. Look at the first option, air voids increases initially and then decreases. Actually, air voids continuously decrease as percentage bitumen increases. Here percentage bitumen, if I take on x-axis, and air voids, as you increase bitumen, bitumen is coming and occupying the voids. So air reduces, bitumen actually increases. So the option A is wrong. Air voids increases initially and then decreases. Actually speaking, it is continuously decreasing. Now coming to option B, voids filled by the bitumen increases monotonically. Now as you keep on increasing the air voids, I am taking same percentage bitumen on x-axis, voids filled by bitumen. As air is reducing, the bitumen content increases. So this is ulta to this, ulta to this. This is continuously increasing. As air is reducing, this mirror image will come into the picture. Voids filled by the bitumen continuously increase. Continuously increase, nothing but monotonically increasing. So voids filled by the bitumen V of B increases monotonically. This is the right option. Coming to the option C, stability. Marshall stability increases initially and then decreases. This is also a true statement. Marshall stability, nothing but strength. As a percentage bitumen is increasing, Marshall stability increases as bitumen content is increasing. Too much of bitumen reduces strength again. So the option C is right. Stability increases initially and then decreases. Coming to the fourth option, flow value, Marshall flow value, nothing but deformation at failure, increases monotonically. As you keep on increasing the bitumen content, so percentage bitumen content, Marshall flow value will be increasing monotonically again like this. This is a concave type, this is a convex type, but this is increasing continuously, voids filled by the bitumen. And Marshall flow value also initially having less slope and having higher slope as you increase the bitumen content. This is also increasing monotonically, this is also increasing continuously monotonically. So it is also a multi-select question, except option A, all other options are correct. These are the three questions through the memory of the students. The rest of the questions, as and when they come, I will try to give you at the end. Thank you.
Friends, let us see about hydrology and irrigation, afternoon session. First one is match the following from hydrology. Horton's equation we know pretty well, it is for infiltration. Muskingum equation is for channel routing, hydrologic channel routing. Penman's equation is for evapotranspiration. First and two are not there. So the correct matching is P4, Q5 and R for 3. This is the correct option. Let us see the second question. A circle radius 30 km has 5 rain gauges as shown in the figure G1, G2, G3, G4, G5. The annual rainfalls are given in millimeters. Using the Thesian polygon method, what is the average rainfall over the catchment? Our problem is to calculate what is the influence area for each rain gauge station. When you join G1 and G5, this is the midpoint. G4, G5 is the midpoint. G5, G3 is the midpoint. So if you join, you are going to get the influence area for G1. This is radius is 30 km. This will be exactly 30 kilometer because it's the midpoint. So it is 30 by 30. A1 will be 30 into 30, 900 square kilometers. A2, A3, A4, A5 are equal areas. The remaining 4 stations. Total area of the circle minus area given by this by 4. Therefore, pi r square minus area of the first rain gauge station divided by 4 will be the each rain gauge station's influence area. Pi into 900 minus 900 divided by 4. I know A1 to A5, I know P1 to P5. Formula for P bar will be sigma Pi Ai divided by sigma Ai. That is 910 into 900 plus 930 into A2, 925 into A3, 895 into A4, 905 into A5. If you sum up these values, you are going to get around 911.00 millimeters will be the average rainfall. A simple TCN polygon method. The third question is in irrigation engineering. As you can see, canal is running at lower elevation, drain or stream is going at higher elevation. Maximum flood level of the canal is not touching the bed level of the stream. So this is definitely type 2 cross drainage work without siphonic action. Type 2 cross drainage work without siphonic action is nothing but superpassage. The correct answer for that is superpassage. These are the questions we obtained so far. For the further questions we get, we will see at the end of the session. Other faculty members are following. Good luck.
Good evening, students. I welcome you all on behalf of ACE Academy. Let us look at the questions which we have gathered in the subject of fluid mechanics, FM1 rather, in the evening session. Let us take the first question. The first question we have got is a theoretical question. Now the language over here is very important. Let us reach each option since we can have multiple options correct. The question says which of the following statements is or are correct. The first statement over here is the vertical component of hydrostatic force on a curved surface is equal to weight of the fluid. Now if you recall, we are having two types of forces acting on a curved surface. One is a horizontal component of force and the other is a vertical component of force. The formula for vertical component of force, it must be exactly equal to weight equivalent force. It is not exactly weight, but weight equivalent force. That is equal to gamma times volume, or let us say rho g times volume. So first statement can be taken as correct. It is equal to weight of the fluid. Fine. Next statement. Momentum flux correction factor in a pipe flow is greater in laminar compared to that in turbulent. Now if you recall, correction factors are coming by the virtue of deviation from uniform velocity profile. In the case of laminar flow, since we are having a parabolic velocity profile which has far more deviation from uniform compared to the logarithmic velocity profile of turbulent flow, therefore the correction factor will be higher in the case of laminar flow. As a matter of fact, if you remember, the correction factor in laminar flow is 1.33 for momentum and 2 for energy correction. In the case of turbulent flow, it depends on the intensity of turbulence, but whatever may be the intensity of turbulence, this will always be less than 1.33. It might even approach 1. So second statement also over here is correct. Statement C. Statement C over here is if streamlines and equipotential lines of a source flow are interchanged, the new flow formed is a sink flow. Now source and sink, these things belong to the concept of potential flows. Let us see what is source flow. Let us say from a particular point, you are having a flow originating and moving out radially. In such a case, the streamlines are going to be radial in nature. These are the streamlines we are going to have. Now, if streamlines are going outward, this is called as source flow. If streamlines are coming inward, it is called as sink flow. And the equipotential lines, which are always orthogonal to streamlines, are concentric circles. Okay? So let us say this is source flow we are having. Source flow we are having, right? And the circles over here are equipotential lines. Now, if we interchange, that means the circles over here become streamlines, and the radial lines coming out becomes equipotential line. Then what flow is it? It is going to be a case of vortex flow. If you remember from the concept of vortex motion, you should recall that the streamlines in the case of vortex flow, plane vortex flow, are supposed to be circular in nature. Okay? So this statement is wrong. This statement is wrong because the new flow formed has to be a line vortex flow or plane vortex flow, let us say. Okay? Statement D over here. In turbulent boundary layer over a flat plate, the boundary layer thickness is proportional to the square root of distance from the leading edge. That means he's saying delta is proportional to x power half. This is true, but for laminar boundary layer over a flat plate, it is not true in the case of turbulent boundary layer over a flat plate. If you recall, turbulent boundary layer grows much faster compared to laminar boundary layer, since the value of delta over there is proportional to x power 4 by 5 or 0.8. Okay. So this statement also is wrong over here. So the correct statements over here are option A and option B. Moving further to the next question. This is a very, very simple question we are having from a simple manometer concept. Very fundamental question. The question says that you are having a pipe containing oil and that pipe is having a manometer connected. The manometric fluid is mercury, which is having a specific gravity of 13.6. Find the pressure in the pipe. So let us say this is a pipe we are having. Let me make it a bigger pipe. We are having a manometer over here. This is mercury over here. Okay? What is the pressure in this particular pipe? We have to find out. To find this out, let us say this point over here, since it is exposed to atmosphere, the gauge pressure at this particular point is supposed to be 0. Now, if I go down by a distance of 25 centimeter, I'll find an isobar over here. This is an isobar because this point and this point are the same elevation level. Fluid is continuous. Furthermore, this point and this point also belong to the same isobar. So if I take this point as point A and this as B, I can say pressure at A and pressure at B, both of them are same. Let us start now. From this particular point, I'm starting, so 0 plus. Since I'm going down, the pressure is supposed to increase, therefore plus. Gamma of mercury multiplied to how much height? 0.25 meter. I have reached till here. Reaching till here is as good as reaching to this particular point because we are on an isobar right now, on an isobar. Further again we are going down, but this time we are going down with the oil. So therefore plus gamma of oil multiplied to the depth being 0.75. You have reached the point P, therefore we can safely say this is equal to pressure at point P over here. Now I can write pressure at point P is equal to gamma of mercury into 0.25, that is equal to 13.6 gamma of water into 0.25 plus this is 0.8 into gamma of water into 0.75 times, let us say gamma of water I'm taking common. Since the value of G is given as 9.81, therefore gamma of water is supposed to be 9.81 kilonewton per meter cube. If you calculate this value, this is a very simple calculation, you will get the value of pressure as 39.24 kilopascal. Now mind you, the pressure we have got over here is gauge pressure. Now I cannot assure you what was asked in examination, since this is what we have got from students. If the question was regarding the value of absolute pressure, they should have given you the value of local atmospheric pressure. And if so, we can say the value of absolute pressure is equal to how much? It is equal to P naught plus this gauge pressure. Again, the units over here are important. You have to check what units they were asked in. Fine. These two questions are the questions we have received in FM1. If any questions are found further, we'll let you know, sure. Thank you. Let me hand it over to the next faculty.
Yeah, hello guys, good evening. Myself Hazrat. Now we are going to discuss the questions from strength of material. Guys, total 5 questions came from strength of material. Out of that, we received the data of only 3 questions. We are going to explain those 3 questions now. Okay, coming to the first question, guys. They given the state of stress. They're asking us to find out what are the stresses in x direction and y direction, guys. The easiest way is using the equilibrium, my dear student, just equate the forces in the left direction as well as right direction, guys. Now take a point here. As you know that to keep the element in equilibrium, we have to equate the stresses or forces, guys. We have to equate the forces. So forces must be equal to area, stress multiplied by area. As given the dimensions that PQ equal to 4, this equal to 3, this equal to 5. Assume this is the angle equal to theta. Okay, now substitute. This side, how much, guys? Sigma x into, assume depth of the element equal to 1. So area must be equal to 4 into 1. Next, downward, sigma y into 3. Next, this side we are having 120, which is making an angle of theta. If this is theta, this angle also will be theta. Next we are having 70. Now listen carefully, sir. If this is theta, this is also theta, guys. But how much is the value of theta first? Here you can guess directly, you can able to make it. Sin theta equal to how much, guys? 3 by 5. Cos theta equal to how much, guys? 5 by 5. Yes or no? Now, so pretty simple now. All left forces must be equal to right forces. Just equate it. Single step answer, guys. Sigma x into 4. Next, 70. Sorry, guys, 70 into area. 120 into area, guys. Now, 70 left force, my dear students. 70 into 5 sin theta must be equal to rightward force. How much, guys? 120 into 5 into cos theta. Just simplify this one, guys. Sin theta, cos theta we know. Just substitute, you're going to get 67.5. If I find out one, second one no need to find out, guys, because it is matching with only option D. Still, if you want to find out one more sigma y, it's very simple. Upward force equal to downward force, just do the same manner, you will get the answer 213.3 megapascal, my dear students. Now coming to the next one. For the given simply supported beam, find out the support reactions, guys, at P. He's asking support reaction at P. Direct one step answer, my dear students. Assume reaction at P. To find out reaction at P, take moment about Q. If you take moment about Q, all clockwise moments must be equal to how much? Anti-clockwise moments about Q. Now first of all, RP will give you clockwise or anti-clockwise? Clockwise. How much, guys? RP multiplied by 6. Next, 200 will give you clockwise plus 200 into how much, guys? 2.5. Next, this 100 is going to give you again clockwise, 100 into 0.5, 50. Must be equal to 500. If you can resolve, my dear students, 500 cos 60, 500 sin 60. Which one is going to give the moment about this point? 500 sin 60 is going to give the moment, guys. That equal to 500 sin 60 multiplied by distance, guys. How much? 4. So from this, I'm going to get approximately RP equal to 197. So pretty straightforward question, guys. Next, coming to the last question. A shaft is subjected to end torque as given. Then, which of the following statements are correct? Statement 1, statement 2. First, angle of shift he is asking, sir. What is the angle of shift formula? Theta equal to how much, guys? TL by GJ. Substitute, my dear students. Take care of the units carefully, sir. So here, T equal to how much, guys? 100 kilonewton per meter, kilonewton meter. L equal to how much? 5. GJ equal to how much guys? 50,000. 50,000 guys. Going to get 0.01 radians. Angle of twist is what exactly? 0.01 radians. Next, strain energy in the shaft. Strain energy equal to how much guys? I can directly make it half into T into theta. Directly guys. Half into T equal to how much? 100 into 0.01, my dear students. Kilonewton meter I'm going to get. Kilonewton meter means I'm going to get 0.5 kilonewton meter. Now look at the options. Angle of twist has given is 0.1 radius, but how much you are getting, sir? 0.01 radians. So option 1 is wrong. Next, strain energy you are getting is 0.5, but he has given 0.1. So both the statements are wrong, guys. So statement 1 and 2 are correct, wrong. This is the correct answer, my dear students. Statement 1 and 2 are wrong, my dear students. These are the data we have received, my dear students. The rest of the questions we will discuss once we receive the data. Thank you so much, guys. I wish you all the best.
Pointer. Now come to the analysis of the environmental engineering. So in this, the question goes as the elevation is given and temperature is given. So what they're asking is a lapse rate. That lapse rate is nothing but the prevailing lapse rate or environmental lapse rate. So whatever the lapse rate, so lapse rate is nothing but change in temperature with respect to the altitude. So whatever the change in temperature over here, so 16.9 minus 14.2 by 325 minus 5. So if you solve it, this is going to be degree centigrade per meter, but I want in terms of the degree centigrade per every 100 meter, right? If you solve it, you will be getting as a 0.843 degrees centigrade for every 100 meter. But anyways, so I have taken in a reverse way. So finally the answer goes, if it is a NAT, you have to represent as a minus 0.843 degrees centigrade per 100 meters. This is question number 1. And now go to the question number 2. Which of the following are not a disinfectant? So it's not a disinfectant. Out of the forms, this Cl minus, this is a chloride. Chloride is different, chlorine is different. Cl2 is a disinfectant, whereas Cl minus is not a disinfectant. Okay, and OCl minus and O3, these two are the disinfectants. OH minus is not going to be the disinfectant. So the correct answers, which of the following are not disinfectants, are chloride and OH minus. Next, in the context of the water and the wastewater treatment, which of the following are the correct statements? NH3 decreases the chlorine demand, obviously. When we add the chlorine to the water, first of all, it oxidizes the iron and manganese, and then it starts to react with the ammonia, and finally it is going to be remove the microbes. The more the ammonia content in the water, the more the chlorine required to form the chloramines. So NH3 decreases chlorine demand? No, NH3 will increases the chlorine demand. So this is incorrect statement. And phosphorus stimulates the algal and aquatic growth. Yes, in the case of the lakes, due to fertilizers, due to presence of the phosphorus, it is going to be act as a natural fertilizer for the growth of the algae. So phosphorus stimulates the growth of the algae. This is true. Calcium and magnesium increases the hardness and TDS, obviously. So the main multivalent cations that causes the hardness are calcium and magnesium. This is also true. Particulate matter may shield microorganisms during disinfection. Yes, particulate matter, which is nothing but the suspended solids, so they will act as a shield for the microbes. Okay, so out of these the correct statements are B, C and D. Now let's go to the next question. So the theoretical aerobic oxidation of a biomass is given. So this is a C5H7O2N. So they have given the reaction. So this is a chemical reaction and BOD rate constant is given as a 0.23 day at 20 degrees centigrade, neglecting the second stage oxygen demand from its biochemical oxygen demand. The ratio of the BOD 5 days to the TOC. So 5 day BOD to the TOC. And you know that for K value of 0.23 per day, the BOD, 5 day BOD is going to be 68.4% of the ultimate BOD. But first of all, we have to find out the ultimate BOD, right? So now for that, okay, so now if you see here, so from the given reaction, if you observe, so this is a chemical compound. Yeah, so this is a chemical compound, and for this chemical compound, first of all we have to find out the ultimate BOD, and the given chemical compound is completely organic, which means the BOD itself is going to be the theoretical demand. So the ultimate BOD and theoretical demand both are going to be same. From the given equation, if you find out the molecular weights, so if you find out the molecular weight, this molecular weight will be going to as a 113. And for this compound, how much amount of the oxygen required is 5 into 32. So which is going to be 160 parts. You see here, 113 parts of this compound requires 160 parts of the oxygen. So one part of this chemical compound requires how much? One part of C5H7O2N requires how much? So 160 by 113 parts. You solve it, there is going to be comes as a 1.42 parts. But that is going to be the ultimate BOD, because as is the organic matter, so for the organic matter, the ultimate BOD is nothing but the theoretical oxygen demand over here. So, but we want the 5 days, right? So, and anyways, we know 5 day BOD is nothing but 68.4% of the ultimate BOD. So, the 5 day BOD is equals to 1.42 into 0.684. So, this is going to be yield as 0.97 parts. See, I am not going to find in terms of the mg per liter or something like that. So, the final point is, for one part of this chemical compound, the 5 day BOD required is 0.97 parts. And coming to the other one, what they are asking is the total organic carbon. From the given reaction, if you observe in this compound, how much, what is the molecular weight? 113. And in that, how much amount of the carbon is there? 5 mole. Yes. So now, for 113 parts, how much amount of the carbon required is, what is the molecular weight of the carbon? 12, right? So now again, for 113 parts, so if you observe, the molecular weight is going to be the 5 into 12, 60. For 113 parts of compound, it requires 5 into 12, which means 60 parts of carbon. So now what is the total organic carbon required is equals to 60 by 113. If you solve, this comes as a 0.513. 0.513. So now we got the 5 day BOD, we got the total organic carbon. Now 0.97 by 0.513. If you solve it, it comes as a 1.83. The ratio is going to be 1.83. This is the only 2 marks question which requires some calculation. Now let's see the next question. So which of the following statement is/are true for the aerobic composting of the sewage sludge? Bulking agent is added during the composting process to reduce the porosity. No, bulking agent we add to increase the porosity. Bulking agent, it improves the volume. So porosity is going to be increases. So this is incorrect. And in-vessel composting system cannot be operated in the plug flow model. So in the case of the in-vessel composting, there are two types of composting. One is a plug flow mode and other one is a agitation mode. So both modes can be used for the composting, but given is cannot be. So this is also incorrect. And antinocytes are one form of the bacteria. So after the composting, so definitely there must be some bacteria. So this is a true one. And leachate can be generated. So what is the leachate? Leachate is the waste fluid. After the decomposition, it is going to be give a color liquid. So that is known as the leachate. This is also true. So from the given options, C and D are going to be the correct statements. Now, match the following. So they have given the pollutants and what are the harmful effects. Aromatic hydrocarbons. The hydrocarbons are going to be the carcinogenic in nature. So whatever the hydrocarbons that are going to be generated from the automobiles or from the diesel engines, so our generators, whatever the hydrocarbons that generate, they are going to be carcinogenic in nature. And carbon monoxide. We know that carbon monoxide is the major pollutant in the case of the automobiles. So carbon monoxide, they will reduce the capacity of the blood to carry oxygen because they are going to be cause carboxyhemoglobin, right? So, and coming to the sulfur dioxide is going to be damage the chromosomes, and ozone is going to be remove the bronchitis, means ozone is going to be causes the bronchitis. So from the given options, so the correct answer is for A it should be 4. So we can eliminate option C and option D, and if you see the D, for the D it is going to be 2. So the answer is going to be option B. Now come to the open channel flow. So critical flow condition in a channel is given by where alpha is the kinetic energy correction factor. We know the critical flow condition is nothing but Q square by G is equals to A cube by T, and where alpha is going to be the kinetic energy correction factor. From the given options, if we observe, the correct answer is option A only. So alpha into Q square by G is equals to A cube by T. And now, so this is one question where it requires some multiple calculations. If you have attempted this one, fine. But if you haven't attempted also, fine, because it will take a lot of time. It would have killed your time. Okay. So now for this question, the flow rate passing through the channel. So this is a given data. The given data is they have given a channel section. This is a channel cross section, and in that given channel cross section, they made into some 7 sections. They have given the data for 7 sections, 7 details. So the depths they have given. So now let's divide into 7 sections. 1, 2, 3, 4, 5, 6, 7. So, and they mentioned that each section is 1.5 meters apart. So the width of the each one is 1.5 meters, 1.5, 1.5, 1.5, 1.5, 1.5. Now what they're asking is what is the flow rate passing through the channel. So we have to find out the flow rate passing through the channel by finding the flow rate in each channel. So for that, what is the flow rate? Q is equals to area into velocity. And they have given the data velocity, so we need to find out the average velocity. We have 2 formulas to find out the average velocity. From 1 point observation, average velocity is directly velocity at a depth of 0.61. And from 2 point observation, the same average velocity is going to be velocity at a depth of 0.2y plus velocity at a depth of 0.8y by 2. So this is about the velocity. And we have depths also, right? Now what else we required? Area. So area is nothing but b into y, right? We have depth. We need to find out the width, average width. From area volume method, so what we have to do is we need to divide this entire area into zones. You see this first one, this entire first zone, and you see the last one, this zone. For this last zone, the average width, we have one formula. So the average width is equals to B1 plus B2 by 2 whole square by 2 times of B1. So what is B1 here? 1.1. You can take this one as a B1, B2 and so on. Okay. So now if you see here 1.5 plus 1.5 by 2 whole square by 2 times of 1.5, this comes as 1.6875. For the first zone and for the last zone, we have the same value. And for the remaining zones, if you see the average width everywhere, so you take half of this section, you take half of the section, half of the section, everywhere the average width is going to be same. So if we plot the data, the average width for all this one, so you can see the you can see the average width for this one, for this average width is going to be B average for each and every one, 1.6875, and for this one it is going to be 1.5, 1.5, 1.5, 1.5, 1.5, and again he is going to be 1.687. So this is the width. Width is there, depth is there, and now coming to the velocity. So we have to find out the average velocity. For finding the average velocity, we know by using this formula, for the first one you can see this is a direct value, and for the last one this is a direct value. But for the middle one you have to take the average of those values. So if you find out those, average velocities for all the 7 sections, so you will get that average velocities as 0.4, 0.73, 1.16, 1.175, 1.11, 0.07, and 0.42. So we have the width, we have the depth, and we got the average velocity. Now come to the final discharge. So average width into depth into average velocity. If we find for each and everything 0.27, 0.7665, 2.08, 2.4675, 1.8315, 0.084, 0.3189, and this is the flow rate for each and every section, right? I want to find out the total. So for all this you just add on. If you find it out, that's going to be 7.826 meter cube per second. If they would have asked rounded to 2 decimals, then 7.83 meter cube per second. There is one hell of question where you require a lot of time. Okay, so that's all about the environmental and open channel flow.
Right. Right. Now here I will discuss structural analysis subject and design of steel structure. So this is the first question. This is a question from ILD. Muller-Breslau principle is used to analyze of. Okay. So I told using this principle we can draw ILD for statically determinate and indeterminate structure. Okay. For any structure, is it determinate or indeterminate? Okay. But these are used to draw ILD for any force stress functions. Okay. Then option A is correct. Then second question. Okay. So in this question he asking to find the force in this member. Okay. But here these hinges are not exactly at the joint. These three hinges are next to the rigid joint. Nothing but this is nothing but a link only, right? Okay. So this is the, we can call it trussed beam. Okay. What it's called? Trussed beam. Now this is the beam and this is the strut. So strut is a compression member, right? Okay. Then we'll mark the force in this member is compression. Okay. Force in this member is compression. Right. Now, so this is the hinge. At the hinge moment is 0, right? Okay. Now I'll separate this structure. I'll make it two parts. Just we'll cut it like this. Okay. Now this is the left part and this is the right part of the structure. Now we'll do analysis only for right part of the structure. So here moment at P is 0, right? So moment at P is 0. I told this is the link, it is a strut compression member. Just we'll draw the free body diagram of right part of the structure. So this is 10 kilonewton. So this is the strut. So strut is a compression member. Just I am marking forces here. Compression. Okay. Right. Now there is a hinge here and this is the force F1. Okay. Just consider this is the theta. Okay. So here given this distance is 1.2 and this distance is given 1 meter. Right. Students, now this is the theta will resolve in vertical and horizontal component. Okay. If we resolve in vertical direction, so here it is F1 sin theta. If we resolve in horizontal, okay, so here horizontal component is, this is F1 cos theta. Okay. So this is the hinge, right? At this hinge this is the point P. Now moment at P is 0. So anti-clockwise negative, clockwise is positive. Right. Now this 10 is clockwise, plus 10 into what the perpendicular distance, this is 0.6 and this is 1.2, then this is 1.8. Okay. Then this is F1 sin theta, this is anti-clockwise, okay, minus F1 sin theta, what the perpendicular distance, this is 1.2 equals to 0. Okay. So from this equation we will get the force F1 sin theta, this is 18, right? Then here F1 equals to 18 divided by sin theta. Okay. Right. Students, this is the horizontal component F1 cos theta, right? Nothing but force in this member is F1 cos theta only. For example, force in this member, just I am writing here, this is FPU. So here FPU equals to F1 cos theta. Okay. So from this we got F1 value, this is 18 divided by sin theta into this is cos theta. Okay. So from this, what is tan theta here? So tan theta equals to 1 by 1.2. Okay. Then this is cos theta, right? Then this is a 1.8 into 1.2. Okay. Then So here we have divided by 1.2, right? Yes or no? Okay, divided by 1.2 here. Then this you'll get 15 kilonewton. Okay, right. Next question. Find the moment at the fixed end A. We have to find the moment at A. Okay, this is the symmetrical frame, right? So if it is symmetrical frame, we'll use the shortcut method of moment distribution. So how to use the shortcut method of moment distribution? So this is the section, this is exactly the center, right? Okay. Now because of symmetry, so what is the moment at B? W into L by 2, right? Then this is WL square by 2 and here WL square by 2. Okay, right. Here this is B and for example this is C. Okay, here section is passing through member, right? If the section is passing through member, we will consider half of the stiffness. This is the shortcut. Okay, so this is BC dash equals to half of stiffness of BC. Okay, then what is the stiffness for member BA? Far end is fixed support, then 4EI by L. Then far end is rigid joint, 4EI by L. Okay, this is half of 4EI by L. Then this is 2EI by L. Then what is the total stiffness at joint B? Then this is total 6EI by L. Now can you find the distribution factor for member BA? Okay, so distribution factor for member BA, this is the stiffness for member BA, then total stiffness at joint B. So distribution stiffness for member BA is 4EI by L, total is 6EI by L, then this is 2 by 3. Okay, now moment for member BA equals to distribution factor for member BA. What is the moment at B given here? WL square by 2. Then this is WL square by 3. Okay, the students, far end is fixed support, half of the moment will carry your same direction. It means moment at A equals to half of moment BA. Then this is WL square by 6. Okay, what is the moment at A? WL square by 6. Next question. All four members AB, BC, CD, AD have same length and Fresnel rigidity also same. All joints, that is A, B, C and D are rigid joints. Okay, midpoints AB, BC, CD and AD are denoted by E, F, G, H. So frame is in unstable equilibrium. Under the shown force, magnitude P acting at E and G, which of the following are true? Okay, so these are the given shear force. For this frame, this is the box frame, we'll draw the bending moment diagram. Okay, then this is we can mark the moment here anti-clockwise, here clockwise. This is anti-clockwise, then this is clockwise, this is clockwise, then here anti-clockwise. Okay, then due to symmetry, opposite direction, same. This is clockwise, right? So this is anti-clockwise, then this is clockwise, then this is anti-clockwise. So this is anti-clockwise, here clockwise, and this is clockwise, anti-clockwise, clockwise. Okay, now we'll draw the bending moment diagram for this case. If we draw the bending moment diagram, so this is the diagram due to only movements. Okay, then there is a load, point load, right? So for point load, so only shaded portion is bending moment diagram. Only shaded portion is bending moment diagram. Right. Students, if I take member AD, So this is A, this is D. Here movement is anti-clockwise and this is clockwise. Okay. Due to symmetry, for example, movement at A, movement at D, both are same magnitude. Okay. If both are same magnitude, then here vertical reactions are 0. If vertical reactions are 0, then what is the shear force diagram? Shear force diagram is straight line. Okay. Right. Now we'll draw the deflected curve for this case. So from bending moment diagram, we can draw the deflected shape. So this is the elastic curve or deflected curve. Right. Now we see the statements. Shear force at point H and F are 0. Okay. So what is the shear force here? This is the point H. Okay. And due to symmetry, so this is point H and this is the point F. Yes, shear force at point H is 0. So this is correct only. Okay. Next, vertical deflection at H and F equals to 0. Vertical deflection at H and F. Students, this is the vertical deflection at H, this is the vertical deflection at F, right? Is it 0? No, it is not 0. So option B is wrong. Next, this is the slope at E, slope at point E, point F, point G, point H are 0. Now this is the slope at E. Okay, now this is the slope at E, this is the straight only na. Now here slope at E is 0. Okay, next slope at F. So where is point F? Yes, this is the point F, slope at everywhere it is 0 only here at these 4 points. Okay, then C is correct. Next, horizontal deflection at point H and F equals to 0. Now students, this is a symmetrical frame, right? Due to symmetry, this can't free to move in horizontal direction. Now here horizontal deflection is 0, okay, and horizontal deflection at point F also 0. Okay, so right. Next we'll see the design of steel structure, only one question. Okay. Right. Here given two plates are connected by fillet weld. Size of fillet weld is given 10 mm and subjected to a tension. Okay. And thickness of each plate is given 12 mm and yield stress is given, ultimate stress is given. Okay. And the welding is done in the workshop, that is partial safety factor given 1.25. This is 1.25. As per the limit state method IS 800-2007, the minimum length, okay, each side is asking, okay, and the load is given. So P is equals to given 270 kilonewton. Students, to find the length of weld on each side, so this is LW1 and this is LW1. Okay, the students, for safety, load less than or equals to design shear strength of fillet weld. Okay, so here load is given 270 into 10 to the power of cube equals to, what is the design shear strength of fillet weld? Length, effective length equals to into effective throat thickness, then this is Fu divided by √3 gamma mw. Okay, so this is given 410. Okay, and the partial safety factor is given 1.25. Okay, the students, here LW equals to LW1, two sides, right? Okay, then LW equals to 2 times of LW1. So we have to find the LW1 only, right? Okay, then here effective throat thickness equals to 0.7 into size of weld. What is the size of weld given here? So size of weld is given 10 mm. Okay, then from this equation you will get the effective length, some 203.68 mm. Okay, but we need length on each side, so 203.68 by 2, so approximately 105 mm. Okay, then option B is correct. Okay, that's it.
IS 456-2000 refers to concrete with design mix having tell me audible no check now ready once again go back please wait. Okay, dear students, from RCC, they have given 3 questions. Let us see. The first question, M20 concrete as per IS 456-2000 refers to the concrete with a design mix having given options A, B, C, D. A, an average cylinder strength of 20 megapascal, a 5% of cylinder strength of 20 megapascal, a 5% of cube strength of 20 megapascal, D, an average cube strength of 20 megapascal. Here given that M20 where M refers to mix and 20 refers to characteristic strength of concrete. If you check the definition of characteristic strength, easily you can answer to this question. The definition for characteristic strength is, it is a value of strength of material below which not more than 5% of test results are expected to fall. It is given related to the cube strength. So you can eliminate option A and option B, and 5% given in among option C and D, only one option, that is option C. Option C is correct. Okay. Then move to next question. The ultimate moment of resistance for given cross section given below. Use M25 and Fe415 grade steels and given cross section here. My dear, if you observe the word given in this question, ultimate, which indicates use limit state method, not mentioned here, a limit state method or working stress method, but in syllabus if you check, both methods available. Here you need to understand from the word ultimate, use limit state method, right? They are asking to find out the moment of resistance given one cross section. So find out first effective depth of the beam, because given overall depth of the beam and effective cover. Effective depth is equals to overall depth minus effective cover to tension steel. Here given overall depth is 600 mm, effective cover given 45 mm. If you simplify, you may get 550 mm. After getting effective depth, then you can find out limiting depth of neutral axis. Limiting depth of neutral axis depends upon grade of steel. Here given grade of steel is Fe415, for which XU max is 0.48 D. 0.48, effective depth of the beam is 555. If you simplify this, you may get the value 266.4. 266.4 mm. After getting the limiting depth of neutral axis, then you can find out actual depth of neutral axis simply by equating compressive force to tensile force. My dear, compressive force is equals to tensile force, where compressive force is 0.36 FCK BXU equals to tensile force 0.87 FY AST. Let us substitute the values, then you will get the actual depth of neutral axis. My dear, 0.36 FCK.
given grade of concrete is M25. So, FCK value you can write down 25 into B here given 300 mm into XU equal to 0.87 FY 415 AST here given 3 numbers 28 mm diameter. So, area will be 3 into pi by 4 into 28 square. My dear, after simplification, you will get XU value as the 247 mm. After getting actual depth of neutral axis, you can compare with the limiting depth of neutral axis, that is XU and XU max we are going to compare. Here this is XU, this is XU max. My dear, XU is less than XU max, therefore the given section is under reinforced section. For under reinforced section, we have to find out moment of resistance MR equals to T into Z. That is, with respect to tensile force, we are going to find out moment of resistance. It is a tensile force into lever arm is D minus 0.42 XU. Okay, my dear, let us substitute the values 0.87 F5 415 AST 3 into pi by 4 into 28 square into, I can write here, D is 555 minus 0.42, XU value we are getting, my dear, 247, which is equal to, my dear, after simplification, you may get the value 300.968 into 10 power 6, directly I am writing in kilonewton meter. This is the answer. Okay. Then move to next question. Shear design of RCC beams, which are two. Given 4 options here, it is the MSQ type question, my dear. As per IS 456-2000, the nominal shear stress in beams of varying depth depends upon both design shear force value as well as design bending moment. Yes, it is true. If you check the nominal shear stress, tau V is equals to Vu plus or minus Mu upon D times tan beta upon BD. So, tau V depends upon Vu as well as Mu. So, A is correct. Then come to the beam. Beams without shear reinforcement, even it adequate designed for flexure, can have brittle failure. This is brittle failure. Brittle failure. My dear, beams without shear reinforcement. Yes, there is a possibility. Beams without shear reinforcement, even it can be adequate for flexure, can have a brittle failure. Yes, 2 is correct. That is B is correct. Then coming to the C, the main, that is the longitudinal reinforcement, plays no role in the shear resistance of the beam. This is wrong. My dear, partly shear resisted by longitudinal tension steel also. That's why C is wrong. Then D, excessive shear reinforcement can lead to compression failure. No doubt, if you provide excess shear reinforcement, which leads to, my dear, diagonal compression failure, it is a compression failure. Yes, it is correct. So, A correct, B correct, D correct. It is MSQ type question. Thank you, my dear.
Okay friends, now we will discuss about surveying questions. So the first question, a ground area of 3 km by 6 km appears as 3 cm by 15 cm on a photograph. What is the scale of map? So he is asking us to find out the scale of map. So here if you see, it is given 3 centimeter 3 centimeter by 15 centimeter, which appears of 3 kilometers by 6 kilometer, right. So here if we calculate for 1 centimeter square, we can write it as 3 by 6 kilometer square divided by 3 by 15, let us say centimeter square, right. So for 1 centimeter it will be under root of the above value 3 by 6 divided by 3 by 15, right. So if you solve this, so you will get 1 centimeter is equal to 632.455 into 10 to the power of minus 3 in kilometers, right. So he is asking us the scale of the map. So here if you observe, the units are centimeters here, and if you observe here it is kilometers. Let me convert that kilometer into centimeter. So 1 centimeter is equal to 632.455 into 10 to the power of minus 3 is the existing value. I am converting kilometer to meter 10 cube and meter to centimeter 10 square, right. So this minus 3 and plus 3. 1 centimeter is equal to 63245.5. So the scale 1 representative fraction, if we write like this, so it will be 1 by 63245, right. So 1 centimeter is equal to 63245.5 centimeters. So that will be turns out as representative fraction 1 in 63245. This is the scale of the map, right. So let us solve the second question. True bearing and magnetic bearing of a line are 180 degrees and 183 degree 30 minute respectively. What is the magnetic declination? So we know the formula. True bearing is equal to magnetic bearing plus declination. D stands for declination here, right. So he is asking us to calculate declination. So declination is equal to true bearing minus magnetic bearing. So what are the values given? True bearing and magnetic bearing are 180 degrees and 183 degree 30 minutes. 183 degree 30 minutes, right. So you will get minus 3 degree 30 minutes. So here minus indicates western declination, 3 degree 30 minutes west, right. So this is the declination, 3 degree 30 minutes west, right. So let us solve the next question. A delivery agent is at a location R. To deliver the order, she is instructed to travel to location P along the straight line paths of RC, CA, AB and BP of 5 kilometers each. The direction of each path is given in the table below as whole circle bearing system. Assume latitude L and departure D of R is 0, 0. kilometers. What is latitude and departure of point P in kilometers? So here he has given the direction, nothing but a bearing. That bearing is given in whole circle bearing system, right? So here there are 4 lines and 4 bearings given, and he is asking us to take the R point as 0, 0, the latitude and departure of that point as 0, 0, right? So by using this data, first step we have to calculate consecutive latitude of each and every line, right? So see here, consecutive latitude. So we know how to calculate consecutive latitude and consecutive departure, right? So latitude is equal to L cos theta and departure is equal to L sin theta, right? By using these 2 formulas, we can calculate all the values of consecutive latitude and all the values of consecutive departures, right? So here he is asking us to calculate the point P. So we have to calculate total latitude of point P, right, is equal to total latitude of point R plus algebraic sum of all other consecutive latitudes, right? Nothing but consecutive latitude of C, consecutive latitude of A, consecutive latitude of B and P, right? So here I am writing like this, consecutive latitude of C plus consecutive latitude of A plus and so on, right? So here the latitude and departure of R is given as 0, 0. So you can see here. So latitude and departure of D of R, right? Latitude L and departure D of point R is given as 0, 0. So right. So total latitude of R is 0. Next, minus 2.5. As we are taking algebraic sum, we need to consider the sign also. Plus 5 plus 0 minus 2.5. So it will gives you 0, right? So this is total latitude of point P. So in the similar fashion, if we calculate total departure of point P, so that will be total departure of point R plus, in the similar fashion, consecutive departure of C plus consecutive departure of A plus and so on, right? So substitute 0 plus 4.33 plus 0 plus 5 minus 4.33. So the answer is 5. So the total latitude and departure of point P is 0, 5. Right? So let us check the options. Where it is latitude 0, departure 5. So option A. Right? These are the questions from surveying.
Let us go ahead with numerical ability questions of afternoon session, my dear friends. See the first question, they given they have 3 red balls, 5 green balls and 6 white balls are there in a basket. What is the minimum number of balls you must be picked? The condition you have to satisfy is at least 2 same color they want. At least 2 same color they want. How many minimum balls you need to pick from the basket, right? See, worst scenario, first ball you taken, ball 1 you taken, it is red one. Ball 2 you taken, it will be green. Ball 3 taken, it may be white. Worst scenario. Sometimes you may get the things with the 2 balls picking itself. First ball red, second ball green, third ball is white. Fourth one for sure, it may be red or it may be green or it may be white. Definitely with 4 balls, 100% sure, we'll get that 2 balls of same color. Question is at least 2 same color. At least why? Because of you picked 4 balls, right? Among that here red also may be a chance. Red, red, white, red or red, red. Okay, all red also possibility. But I need to pick 4 balls to ensure that 2 of same color guarantee. Yeah, you can see here. This is one situation I explained. Okay, all 3 are different. First 3, whatever taken is different. Then last one, fourth one, if you take red or green or white, definitely you will get 2 of same color. So answer is 4, dear. Answer is 4. Minimum, okay, 2 balls of same color will come. Minimum 2. It may be 3, 4 also chance is there. See the next question. This is regarding that such indices are powers are exponents. So 4 power 8 power x is 256. We can write 256 as 4 power 4. Now here as bases are same, powers must be same. 8 power x must be equal to 4. We can write this as 2 cube, 8 as 2 cube. So 2 power 3 into x, 4 as 2 square. Again as bases are equal, powers are equal, we got simply x value 2 upon 3 or 0.66. As per the information given, we have option 2 by 3. We can go with x value 2 upon 3. Right. Now see the third question. They given a square 3 rows and 3 columns square box is given in the question with 3 rows and 3 columns. Now question what they are asking, in how many ways you are going to shade this square grid, 3 rows and 3 columns, how many ways you are going to shade this. Condition is each row and each column have exactly only one shaded cell. Each row and each column should have exactly one shaded cell, right? Now see this, first one, okay, one row, okay, or each column, you should have only one shaded area, right? Now let's see, suppose I am shading this column or maybe this row, you take one row or one column like that. First I want to shade this row, I can shade here or I can shade here or I can shade here. That row, okay, only one box should be shaded. I can shade this one or this one or this one, 3 ways. 3 ways I can do. That's what 3C1. Okay, I have to shade this row, one box. It may be first one or it may be second box or it may be third box, right? Then next one, okay, next row I am going for. Suppose this is what, okay, I've explained 3. Fine, you got that 3. How you got? This row, it can be first one or second one or third one. Fine, now one row, okay, one among that is fixed. Right now, if I go for here, column will have 2. I want exactly 1, only one box to be shaded. Already column is having 1. Now I have only 2 choices for second row. In second row, I need to fill one of the box. This one I cannot fill because column will have 2 shaded. So I have only 2 choices, either here or here. Only 2 choices in second row to fill. Either it may be this one or this one. Let's say this. So 2C1. Second row, okay, one of the box to be filled. It may be this or this, not this one. Then third row, one box. Here, I am going with each row, one box to be filled. Parallel it will cover, column as well it will satisfy, right? Then third row, okay, I have to fill this one, means already available. Okay, column should have only one box to be filled. Then this one should be there. So if you see 1C1, only one choice, 3 into 2 into 1, we can say 6. 3 into 2 into 1, 6. Some of you have a doubt, sir, how you got that 6? Can you represent that? Yes, we'll show that all 6 arrangements here in a fast mode. You can see I'm just giving that 6 diagrams here. I'll show all those 6 arrangements. What is the possibility? Three rows and 3 columns, that square grid. That shape may not be, looks like square. Okay, don't worry about it. I hope you understand what is the information we are conveying. 3 rows and 3 columns. Right now, I'll just show the condition is the only thing. Each row or each column, only one box to be shaded. First I shaded here. Okay, I shaded here. Right, then this shade, second shade, if I shade in this first one, I can go like this or like this, or I can go like this or like this. This is 2 things, okay. You can observe here, each row or each column, only one box is shaded, first 2. Next, I'm going with this. When I go with that, okay, it may be here, or it may be here or here. You can observe this also, each row or each column, only one box is shaded. Then finally, like this. You can see these are the 6 combinations where that entire condition, whatever they mentioned, 1 row, 1 column, only one box to be shaded will satisfy. Now see the next question, my dear friends, related to seating arrangement, circular arrangement. Okay, here you see they mention circular arrangement. You have 3 pairs, okay, husband and wife should be like a 1 pair, the husband and wife, 3 such pairs are there, total 6 people, but 3 pairs are there. 3 pairs if you want to arrange in a circle, 3 pairs, if you want to arrange in a circle, we have 2 factorial into. Now here, first pair, that is husband and wife, internally they can arrange H1, W1, internally they can arrange in 2 factorial, H2, W2, internally they can arrange in 2 factorial, this H3, W3, this can be arranged in 2 factorial like that. Internal arrangement is this. This is okay. You know, in our regular classes we given y, we have to do n minus 1 factorial as well. So finally, if you see, this is 2 power 4, which is 16. There are 16 ways you can arrange as per the condition they given. Okay, husband and wife must be together, but they have to internally, see they clearly mention, husband sits next to his wife. Okay, whether it is left or right, that's what internally 2 factorial we mention. And this is antonyms they given in verbal. You can see, okay, opposite words, often and seldom are opposite. Similarly, kind and cruel are opposite. We received few set of questions from students. Okay, once we got all the data, we'll definitely upload the solutions in our portal. Okay, thanks for the opportunity, dear.
Okay. Now I will discuss the previous year's questions on the mathematics topic. Now this is the question from the differential equation topic. Now let us look at the question. We are given the third order differential equation with the constant quotients, and also it is a homogeneous equation. And its solution is also given. The solution is given in the form of linear combination of 3 independent solutions. From this solution, we try to find out the alpha and beta, and then we find out the alpha plus beta 1, the value of the alpha plus beta 1. Once you know the solution, we can set the coefficients of x in the exponential functions, which are the roots of the auxiliary equation of the third order differential equation. Because of this, directly we can find the alpha and beta, and then we can write the sum of the values alpha and beta. Now, here let us suppose that m1 equal to 2.5, m2 equal to alpha, and m3 equal to beta. So once you know the roots, then we can add the sum of all the roots. The sum of all the roots is the coefficient of this d square y by dx square. So we can add the m1 plus m2 plus m3 equal to 5.5. But m1 is already known, so we can add the 2.5 plus m2 plus m3 equal to 5.5. Other two roots are alpha and beta only. So alpha plus beta, m2 equal to alpha and m3 is beta. So alpha plus beta equal to 5.5 minus 2.5, this is equal to 3 only. So we are asked to find the sum of the two unknowns, which are the roots of the auxiliary equation of the differential equation. So the sum of the two unknowns is 3 only. This is our answer only. Now we go to the next question. Now this is a question from the vector calculus part, and that too this is a direct question. It is a standard identity. We are given the two functions. One is scalar function, phi is a scalar function, and mu bar is the vector function. And we are asked to find the divergence of scalar multiple of vector function. Now we operate this divergence on this vector function only, because phi is a scalar function and mu bar is a vector function. The product is a vector function. So we are operating this on this only. Since the divergence of scalar multiple of vector function is equal to scalar into the divergence of vector function plus the vector function f bar into dot del of phi. Now this is the standard identity only. Now here phi equal to phi, f bar is in place of f bar. If you write the mu bar vector, then this identity becomes the second one only. So option B is correct one. Now the next questions will be good.
Now, 3 more questions available in linear algebra topic. Now, we have received 5 questions. Already, sir discussed 2 questions. One is on differential equations and the second one is from calculus. Now 3 more questions which are available in linear algebra. Now coming to this question. Number of linearly independent eigenvectors of the matrix. One matrix given like this, number of linearly independent eigenvectors required. Now first you find the eigenvalues. First you have to write the characteristic equation to find the eigenvalues. For 3 by 3 square matrix, you know how to write a characteristic equation. What is characteristic equation for it? Now, what is characteristic equation for it? CH equation. CH equation means characteristic equation. Lambda cube minus trace of A into lambda square. What is trace here? 4. Plus, next plus minus, next plus. What it is? Sum of the minors of principal diagonal elements. Sum of the minors of principal diagonal elements. What you get here? Plus 3 lambda. Next plus determinant, plus minus plus, next determinant. Determinant you are getting 0 here, is equal to 0. This is a characteristic equation. If you solve it, then what it is? Take lambda common, lambda square minus 4 lambda plus 3 is equal to 0. So what are the eigenvalues? 0, 1, 3. If you solve it, 0, 1, 3. These 3 eigenvalues. Very clear. All the 3 eigenvalues are distinct. If all the eigenvalues are distinct, how many eigenvalues are there? How many distinct eigenvalues are there? That number of linearly independent eigenvectors exist. Since 3 distinct eigenvalues are available, how many linearly independent eigenvectors exist? 3. 3 is the answer. Okay. Now coming to the next question. If x1 is equal to 2, 1, 0, 3 transpose, x2 is equal to 1, 1, 0, 1, 2 transpose are elements of a null space, actually vectors it is. Vectors of a null space of a matrix, 4 by 4 matrix, and rank of A is equal to 2. Then which of the following is the another vector? Which of the following is the another vector of a null space? Maybe from the available data, this is an information. Which of the following is the another vector of a null space? Very clear. One hint. See, 2 vectors of a null space given and rank of A is equal to 2 given. Rank of A is equal to means no doubt that null space contains 2 linearly independent eigenvectors. Very clear. So here x1 and x2 are linearly independent eigenvectors. x1 and x2 are linearly independent means remaining all vectors of null space you can write, can be written as a linear combination of these 2 vectors x1 and x2. Means suppose if x is the vector in null space, you can write it as a linear combination of, so means some k1 into first vector, what it is? 2, 1, 0, 3 plus k2 into second vector, what it is? 1, 0, 1, 2. Very clear. So now from the options verify, no doubt, so k1 into some vector plus k2 into k1, k2 are scalars. Some scalar into first vector, some scalar into second vector must be equal to one of these options. Suppose if it is MSQ question, maybe multiple options are available, but verify here, very clear from option B, very clear, say this, 1, 1 minus 1, 1 is equal to 1 into 2, 1, 0, 3 minus 1 into 1, 0, 1, 2. Check it once. 2 minus 1 is 1, satisfies or not? 1 minus 0, 1, satisfied. 0 minus 1 satisfied. 3 minus 2, 1 satisfied. So option B satisfies this condition. So verify rest of the options, definitely they will not satisfy the condition. Means you should get same values of k1 and k2 for any set of equations. For the rest of the options, you will not observe such condition. So option B only satisfies. So option B is correct. Now coming to the one more question. This is a third question based on particular third question in linear algebra. The Cholesky decomposition of a matrix capital A. If the element LT2 of a matrix is given, one of the element of the decomposition means one of the element of a lower triangular matrix is given, then what is this AT2? A22, what is the principal diagonal element? They are asking here. Now what is A here? What is A? Given A is equal to 8 minus 5 A22. Now, according to Cholesky's decomposition, if A is a real symmetric matrix, A you can decompose into L into L transpose. A you can write as a product of L and L transpose. What is A? What is L here? A is equal to 8 minus 5 minus 5 A22. What is L? L is nothing but L11. Lower triangular matrix means that is 0. This is L21, L22 into, and the transpose of that matrix you can take L11, 0, L21, L22. Now you compare, if you compare, see this, multiply RHS product of two matrices and compare the elements here, then what you are getting, check it, that is L11 square is nothing but 8. See this. Multiply these two. L11 square is nothing but 8. That implies L11 is equal to root 2 over 8. Next, see, L21 into L22. See this, multiply these two. L21 into L22. L11 into L21 plus 0. L11 into L21 plus 0. What it is equal to minus 5. Next, same. And here A22 required, you need not compare all the elements. That is, you multiply these two again. L21 whole square plus L22 whole square is equal to A22. Whole square is equal to A22. Very clear. From this, already L11 value is available. This is already root 8. This is root 8. Now, what is L21 from this? L21 is equal to minus 5 by root 8. Now, coming to L21 whole square, actually L22 required here, A22 required. Now, L21 whole square, already L21 is available, minus 5 by root 8 whole square plus L22. L22 is already available. L22, 1 point, see, L22 of a matrix L is 1.968, it is available. 1.968 whole square is equal to A22. Verify, if you verify this value, actually here options also available, no need to use calci, think smart, that is option A 11 given, 5 given, 7 given, 9 given. Very clear. So 5 by root 8 means it is 25 by 8. 25 by 8 means what it is, 3 point something. That is 3 point something. Here also you will get 1.968 whole square means 3 point something. 3 point something plus 3 point something means approximately 6.9 something. Nearest answer is 7. So option C is correct. These are the 5 questions available on mathematics. Okay, after getting the complete information, we will upload the remaining questions of mathematics also.
Hello students. Hello students. So far, we have provided the solutions for the GATE 23 civil engineering paper which was held in the afternoon. We tried to provide the solutions for most of the questions which we could gather from the students from their memory. They're all memory based questions. In spite of our best efforts, we could not gather all the questions of this GATE exam. Whatever available, we tried to provide the solutions through our faculty members. Still, I think a few more questions are there for which the full data is not available to provide the solutions. Kindly excuse us. Anyway, nothing to worry about. Very soon, IIT is going to upload the actual gate paper in the website, then immediately we provide the detailed solutions for all the questions that you can download, you can check once again thoroughly. The exact what you call scoring, you can make assessment yourself there. And lastly, some of you might have done well in this examination. For them, we really appreciate, and some of them might have got some disappointment. Nothing to worry, the world is very wide. Have a positive attitude. Whatever the preparation that you have done, whatever the knowledge that you have gained so far in this gate preparation, definitely tomorrow it is going to be helpful for you if you try any other examination. Right? You may get other alternative opportunities. So I take this opportunity to wish you all good luck in all your future endeavors. God bless you.